The broadcast is now starting. All attendees are in listen-only mode.
Hey folks, it's Andy Polk and Jasmine here at FDRA. We hope you're having a great afternoon. We're sorry we started a little bit late, but we wanted to get as many people on as possible. Um, One of the key subjects that a lot of brands and companies have a lot of questions on and are exploring a lot right now are how they cut out design and development costs and increase their speed to market. And increasingly, as people start to look at how they transform their backroom operations, this key term called digitalization keeps popping up. And there's questions around a roadmap to how you digitize your design and development programs, from materials to samples to everything in between. And so we were pleased to have worked with X-Rite in the past, sponsoring different events on this idea of digitization and what they're doing in the space, especially for material visualization and material data that go into PLMs and go into different software programs to help design and development teams, kind of transform what they're doing. And so today I'm pleased to introduce Dr. Mark Ellens from X-Rite. I think most people may know X-Rite from Pantone, their brand that is focused mainly on colors. But they have a great scanning machine and software that they have been using increasingly, and several brands have purchased and are starting to scan materials and bring those into their software and platform. And so with these increasing questions and curiosities around digitization, we wanted to invite them to come and present today on AxF, and what they're doing in the space for digitization. So, Mark, with that introduction, thank you very much, and I'll let you take it from here, folks. Along the way, if you have questions, there is a box on the GoToWebinar mainframe that you'll see for questions. So as you go along, please type in that question that pops up. We'll get to those at the very end, and we'll make sure that any and all questions typed in will get answered today. This is also being recorded, so if folks want, we will distribute it after the webinar, and if folks want to go back and listen again, they certainly can. And of course, at the end of the webinar presentation, Dr. Allens will provide his contact information. So if you want to set up demos or do deeper dives with him, we can do that at that time. So with that, Dr. Allens, please go ahead and take it over, and thank you very much.
Thanks, Andy. Appreciate the introduction. So we at X-Rite here have been doing a little bit of work on scanning materials, and hopefully today you'll get a little bit of an idea of what that means for your design process. And I think one of the things that I wanted to introduce here is just that this is a process of really capturing the full appearance of a material and being able to use it in a way that really expands your workflow. So today we'll go through a couple different things. One is basically the kind of the underlying concept of what we're talking about here, using some PowerPoints, and then I'll follow that with a demonstration of our software Pantora, and then some inclusion of our AxF files into 3ds Max and V-Ray, just to show you how you can work that from end to end. Unfortunately, you're not going to be able to experience the actual hardware. So this is a little bit more difficult to do with a webinar format. And I'll kind of describe that to you, show it to you with some pictures, and be able to point you to the next step if you actually want to experience the hardware in person. So with that kind of introduction, just a little bit about myself. I've been working at X-Rite for 13 years. I've been working in this particular group, working on appearance for about 10 of those years, with a really forward and expansive look at how we can capture every aspect of materials and bring it to the digital format. So keep that in mind, and we'll get on to the actual content. Okay, here we go. All right, so X-Rite as a company, as Andy mentioned, probably not as visible or recognized as Pantone. We own the Pantone brand, but we do have offices all over the world, 800 plus employees, 17 worldwide offices. This kind of color measurement and appearance measurement technology is applicable everywhere. So anywhere that you are interested in trying to figure out how to do this kind of capture, we'll make a solution for you. So the main development areas are here in Grand Rapids, Michigan, which is where I'm located, and then we have additional development in Europe, and that includes both hardware and software. So some of the products, in case you haven't encountered them before, we produce products that have been used for photography, the Great Beth color checker charts, the Pantone fan decks, light booths for doing color evaluation, monitor calibrators, print inline press. If you ever needed to have your custom color made into paint at a hardware store, most likely you're using one of our instruments to do that. And then recently we've been expanding out into different areas, including a lot of the makeup and other mobile-based solutions. So you can look forward to that coming in the future as well. And some of the technology that you'll see today are not shown on the slides because that's the big intro at the end. So why do we want to actually do digital materials? Well, if you look at a digital workflow, here we're talking about taking a product all the way from an initial idea or an initial sourcing situation and bringing a final product all the way to the consumer. To start with, those people who are trying to manufacture or sell materials wholesale into product designers or other products have lots of interest of taking their particular material and making sure that those people who are buying it understand well what it is they're trying to make and what they're trying to produce. And in order to communicate that effectively, the typical usage at this point is to bring the product, the material in person to a show or to a company and make that presentation. This involves a lot of travel, a lot of shipping, and a lot of extra cost. Not to mention the fact that these materials change quite frequently. And so every time you need to do a new batch or a new version of something, you have to create new samples. You have to actually physically make them, and then you have to bring them to show. In addition, once a particular company decides that they want to use a material, they're going to take that material, they're going to figure out if they can produce it. So there's another going back to the manufacturer and making sure that they can produce it. Maybe they've made some tweaks to it. They wanted a different color. They want to make sure that it matches with everything else that they're producing on different materials. There's the whole inspiration process. Maybe the material isn't exactly what they want, but they're using some ideas to produce something new. That goes back to the manufacturers, and this physical process of shipping the information and the communication back and forth from the producer to the consumer, the product manufacturer, really causes a lot of time and headache, and this process happens frequently. Even when you get to the point where you've decided what you're going to make, and in this case, let's talk about shoes. You decided that you want to produce a particular shoe with certain kinds of materials on it. You still don't know exactly what it's going to look like because maybe you have layers, maybe you have different aspects to that material. And so in order to really know, you have to get something made. Or maybe you 3D print it, but it's kind of the same. Maybe the material isn't quite right, but you get the look of it. So, and then ultimately you will need to make decisions about this. Is this really what my consumer wants? Maybe you have the ability for them to customize it. So this particular material is going to exist online or digitally first, and a consumer will be able to select it, and you haven't made it yet. So in each of these areas, the move from an actual physical material to a digital material saves not only the cost of making the actual manufacture of the sample, it saves a lot of time in the shipping, in the communication, in the trials and errors, in the actual production of samples. And it also is able to communicate a lot faster as far as the idea goes, so that you can narrow in on the final product, the final sample that you want to do much more quickly. And so not only you're saving time, but you're also saving money, and you're also being able to communicate your idea even more effectively to this particular idea of coming in and taking your material and pushing it out to the consumer has a way of streamlining this workflow and making sure that you can communicate to your end consumer in a very effective manner, and so that you can have them have the right idea for what you want to actually produce. So ultimately, each of these areas, and not every process is going to use each one of these things. Not everyone will not everyone is going to need every aspect of this, but a digital material can solve a lot of these problems and make things faster for you. So how do these things help your business? First, kind of in summary, I guess, three main areas. Communicate available materials. So from a supplier standpoint, you have a lot of materials that have a lot of options. You want to be able to show those. Maybe you have many more materials than you want to carry in your suitcase. Secondly, accelerate design. So you're getting to the final product faster because you understand how the materials work with your design. And finally, you're engaging your customer in a much more hands-on and direct experience with materials that are of high quality in terms of their appearance. They get a much better idea much quicker. And this goes all the way into now the real-time applications such as virtual reality. So what did we used to do? We used to take these things, and I'm sorry, as in many people are doing this right now. The artistic process of creating materials is still very much used. And sometimes this is just because the material only exists in someone's head. So, but even if you had a real material, the main method of producing that material was also using an artistic process. You have an existing material, but somebody needs to recreate it by hand, digitally. So if you wanted to use this digital process, you had to actually do it, create something in Photoshop, usually take a picture, do some scans, make sure it's in repeat, do a bunch of color management on it, and then you get basically a flat image. This is what is used most often in the industry right now, are just flat images of materials. This has improved recently. We've seen an uptick in the number of people who are using texture scanners. And in this case, we're talking about either an actual scanner, like a flatbed scanner. And there are some tools that you can use to extract out or add to that particular format things like gloss and normal maps and height maps. And that actually increases the complexity of the material and provides a much more realistic look. But it involves quite a bit of hand-holding, and also you have registration issues and things when you're dealing with maps independently. So what we want to do is we want to really push on the accuracy. We want to make sure that we're capturing all the aspects of materials, we're capturing them all together, and we're putting them in a format that you can use as a single material format that contains all of those aspects in one place. And having measured them in a physically correct situation with a physically correct scanner, this material now is physically based. And so you can use it inside of rendering without worrying about whether or not this material is going to violate the laws of physics with color response. So the main idea is that we want to take this highly accurate scan and we want to make it available without having to go back and edit it. And so that's the main objective for the TAC system. So now to talk about digital materials and digital appearance. With this picture of these shoes, these materials were scanned with our AxF into AxF files using our TAC scanner. Obviously, hopefully you can see that there's a good amount of variation on these materials. And so what exactly goes into making these shoes look like this? Well, there's different pieces to this, right? It's not just color and it's not just picture. We just talked about that. What we have is the visual sensation through which an object is perceived to have attributes as color, gloss, texture, transparency, and translucency. And so each of these aspects comes through and produces in your head an idea of what a material should be. But it's not just that material, those material characteristics. Those material characteristics are combined with other things. They're combined with the geometry that you're using. They're combined with the scene that you're using, including the kind of lighting, and they're combined with the viewer, the person who's looking at it. Each of these properties comes together to produce the full appearance of something. But when you're going to use these digital materials, you want to be able to extract them out, extract out the things that are unique to that material so that you can reproduce, you can use that material on any given piece of geometry, in any given lighting situation, and for any given viewer, whether that's a photograph or whether that's a person looking at it. So in this particular case, what we're wanting to do is we're wanting to look at the independent characteristics of that material so that they can be used in multiple situations. So our TAC scanner actually produces an AxF file which contains the optical properties, maybe not from a physics standpoint or all the way from a physics standpoint, but from an appearance standpoint, the optical properties that communicate effectively what that appearance is supposed to be. So some of the maps, which we'll talk about a little bit more extensively when we do a demo here in a few minutes, that we can get are the diffuse albedo map, which is the main color of the object, the normal map, the specular color, and the roughness map. These basically go together and describe the width and the height of the gloss lobe. And then the transparency, this is seeing all the way through an object and having soft edges and things like that. This is particularly useful for meshes. We are currently working on subsurface scattering, so that's plastics, homogeneous plastics. We also have height maps and clear coat maps and a few others. These are not shown specifically in this sample, but because not every material has all those different characteristics to it. So all of these come together to produce a material format, and they're all included in the single AxF file. So what are we talking about with AxF? It stands for the Appearance Exchange Format. And it's the digital twin of a physical material sample, and it comprises the full appearance measurement information plus any metadata, and that's important because this is where you get your connection to the PLM systems. You can customize what you put inside of this material format. It's essentially just an XML format in a binary form. You can customize the metadata to coordinate with whatever PLM system that you want. Now, there's a couple decisions to be made, and it's not you know, it automatically integrates directly with, you know, choose your own PLM system. There's some required work to make them compatible, but it's work on the adoption side, not necessarily a format thing. So you can essentially add any identifiers, add approvals, support your workflow of your material through this, and including any kind of physical parameters that you might need, as well as regulatory parameters or other things that are associated with this material. And then once this AxF file has been produced, we take this and we are able to export it or even use it directly inside of our partners. These are rendering partners who have decided that AxF is a good idea, and they've added support for AxF within their applications. Some of these are, let's see, a couple of them are exports, but many of these are even moving from export to a specific plugin that supports AxF directly. And this gives the highest fidelity format. It supports the most variety of models that are within AxF, and it allows for the best reproduction because the model is usually kept the same as what we're supplying in the format. So a bit on the technology before I get into the specific demo. The TAC system is a standalone system which uses a bunch of cameras and light sources to capture a whole bunch of data. The measurement time goes from 15 minutes to 120 minutes. That's measurement, and I think 120 is a little bit on the outside at this point. So it's about an hour 20, not 120 minutes. So it's to 80 minutes. And then the measurement data size is anywhere from 200 to 120 gigabytes of raw data. That gets processed down into a much smaller file, the AxF file, from 1 to 200 megabytes. That's 1,000 times smaller than the actual raw data. But what you're looking at here are essentially a set of texture maps. And so the specific size of those is governed mostly by how big of a measurement, how big of a sample file that you're measuring. There's a post-processing time, which depends a lot on the CPU that you have running this. And that post-processing time is used to actually produce parameters that go into the model that we're using. These models are both a car paint model, which is a BTF and color table mix, as well as an SVBRDF, which is a kind of a standard texture map format that you see in a lot of rendering engines. As I mentioned, the capture technology here is a bunch of cameras, including a bunch of light sources, 32 LED light sources. 8 of them have spectral filters in front. There's a structured light projector for extracting normal maps and height maps. We have a backlight to do transparency, and the stage rotates so that we can get anisotropic measurements. We have a spectrophotometer too for making sure that the color is calibrated well. In addition, there's a variable linear light scanner. That particular light source is used to get high quality gloss, such as the orange peel on car paint, for example. It can also be used for coated leathers. So here's a nice view of the sample drawer, insertion of a paint sample in there, and then this drawer is closed. That unit that you see, the round unit, is detached and fixed to a rotary motor so that you can move it inside of the dome that's underneath. Once that's been captured. Pantora, which is our software, is used to process that into an AxF file, and I'll show you a demo of this in a minute. And finally, once the AxF is produced, you can use what we call the virtual light booth to do a comparison of your real model with your virtual model. And here's where the interesting part of the validation comes in, because you want to make sure that your digital model is actually a twin of your material. And so in this case, we show on the right-hand side in the front an actual physical material or an object or something that you place in there. And then we can, with some setting up of CAD geometry and applying the material, in the left-hand side in the back, you have a virtual display of that same object, provided you have the right CAD for it. And that particular model is shown at the same time as the material in the front. We show that virtual display on a high brightness display monitor in the back of what is basically a standard light booth with a D65 light source. So the light source is a diffuse light source or a specular light source. These are both mounted in the top, and then provide a very well calibrated, field calibrated monitor that shows exactly the same amount of light as coming from the light booth, so that you have the same visual experience with the virtual light booth as you do with the physical light booth. There are some additional features for this. One is face tracking, so that you can get a very good angular profile, as I mentioned, field profiled on the monitor. So every angle of that monitor is taken into account, so that as you move side to side, the color doesn't change. In addition, we have it gets dynamically calibrated as it's running, and we also measure the ambient light so that we can maintain the right amount of exposure on the monitor. There's a turntable. It's not easily seen in these images, but the digital material and the physical material rotate at the same time, at the same rate, and they're calibrated to be relative to each other. So before I head into the demo, I will mention that there is a free viewer available on the website. You can search for it under Pantora. This will allow you to actually see and use AxF files. If you need some demo AxF files to play with, those are also available on our website. And otherwise, you can contact me and we can talk about doing a demo scan for you to see how it would work in your workflow. I will also mention that this technology, we show it in a lot of shows nationwide, worldwide. And we also have demo locations around the world where the instruments are set up and you can come and visit them, and we will provide some hands-on demonstration and ability to see the hardware in person. So we will not pause for Q&A, and I'll go right to demo here, making sure that my screen is okay. Somebody yell if you cannot see this. So we're good?
Yep.
Okay, so a quick overview of Pantora. I'm not going to spend a lot of time on this, but this is the software that we use to do our processing and to manage our instruments. The basic functionality of the software is organization. So here we have our browser with search capabilities. This is just a flat file format with links to our locations on hard drives somewhere. So if you wanted to take a look at exactly what footwear samples was, it's under my documents, under my AxF file. These can be navigated into a file folder format, etc. But if you need to edit these files, you can just drag them into the material tray here on the bottom, and then these are now accessible to the other panes. Some of the other panes that we have here, we take these materials and we drag and drop them into our representations in the editor pane. What this can show you is the kinds of maps that are included in this file. So in this particular file, we have a height map, a diffuse color map, a normal map, which is shared by the specular and the diffuse model. We have a specular color map and a roughness map. These 1, 2, 3, 4, 5 maps are used to make this full appearance over here that you can see on the right-hand side of the screen. To swap those out, you're just dragging and dropping into here. This one actually has a transparency map associated with it. It's not terribly useful because I don't think this material is transparent. But there is a map associated with that. You can see that it's fully opaque. A height map, a color map, and this particular one has an anisotropic rotation map. And this describes what happens to the gloss lobe as it rotates around. Just another sample. You can see here, this one is similar to the one before. We have a couple different things. There is an option for having not only a ward-based SVBRDF, but we can also use a GGX model, and this is more commonly used in a lot of the media and entertainment applications. And then we also support a Fresnel map now. That's a new feature. This one is great for materials that have varying gloss on them or varying texture characteristics, so that if you look at them at an angle, at a increasingly glancing angle, you can see differences there. So that's what those are used for. Our basic editing features are here with the ability to crop. You can select different maps to use for editing, select crop areas, change gradients, allow them to allow the basic configuration of how to take a material format that looks like this in one square and make it into a repeat like this in the second window. Any changes that you make to any particular map, such as if I would edit the normal map, for example, it would show up here in repeat and then reflect the final edits over here in my 2D preview window. In addition to changing the crop and changing the gradients, and these are all just to make sure that you're getting the seams to be the same intensities so that you don't notice where they're overlapping or where the repeat starts again. Another thing that we have are these seamless options. So if you've done repeats before, you will recognize the min cut algorithm, and this one just takes a kind of an optimized path through the boundary to make sure that the features are not lost across the boundary edges. And this is really good for things like this particular texture, which is a kind of a snakeskin kind of thing. We have other options associated with that, including a linear blend, and then finally the option to do texture synthesis. And this one will actually create a new material using pieces of your original material. Some materials are really good at using this characteristic as a foundation for building materials. Leathers are one of them. This particular snakeskin leather, I think, would not work well, so I'm not going to try it. But in this particular case, and in all cases, you can evaluate these techniques. They're undoable, and you can at any time decide that you want to save a particular configuration as a preset and then go try something else and see if it works. And the idea is that you want the final material to be not only conveying the actual visualization and the appearance of your material, but you want to make it usable in a format that you can show on an object in a way that conveys the appearance without detracting from a particular measurement artifact or something where you've cropped a small area and you can see where it's being repeated. So we want those seams to not detract from the overall appearance of the object, of the material, and be able to communicate your product very effectively. So each one of those things goes into play. Once you've decided that you want to actually use this material in some format, you can actually export these and optimize them for different outputs, and there's a few different ones here. However, I would say that actually Autodesk Bread and V-Ray now have their own AxF imports, which contain the full unmodified versions of these materials, and so it's more recommended that you use the plugins directly. The Mental Ray one is an export, and the Unity one also is export, although I think we have a Unity import now as well. So, so finally, the last portion of this demo will be kind of what this looks in finality. So if you're using 3ds Max, this just happens to be one CAD application that I have access to. And what we're using here are AxF materials with the V-Ray plugin that we have for that. So the way this would work is you would select your particular material that you're going to modify. You would select one of the materials here in your set of materials that you have available for use. You pick that you want a particular kind of material, and in this case, I want to have an AxF material, which should be right here under V-Ray, a V-Ray AxF material. I click OK, and then select a file name. And in particular, I want to do go here to AxF. And now I have these individual materials here that I can just say AxF. I know that my UV spacing on here is about 80 per, so I'm pretty sure that that's the right sizing. And now, because I have this selected, I can apply that to my selected material and do a test render. And you can see now that my snakeskin material is showing up with a bunch of other AxF materials that I have assigned to this shoe. And just like that, I have a rendering using the AxF material. So that part of it has been streamlined quite a bit and is working really well at this point. So with that, I think I will pause. I'll end here and open the lines for questions if people have them related to this. Is that
great.
Yes,
Thank you very much, Mark. And the second half works seamlessly, and the images are pretty awesome to look at. All these different digital tools that you guys have that people could utilize for footwear. So thanks for going through all of that in detail, folks. If you have questions, there's a question box on the right-hand side on the GoToWebinar control panel, and you can just type it in, and we'll get to those questions. There is one question that said, let's see, would there ever be a case where you would use the tack scanner separately from Pantora, or are they both interdependent?
So you definitely need Pantora in order to run the tack. So they're really, tack is it's a machine that basically runs tethered to a computer that can do the processing, the heavy lifting and the processing for it.
Okay.
So it is required to have a Pantora license to run tack.
Okay. Another
but
question.
You can run Pantora separately from the tack.
Okay. Another question is, the question centered on training opportunities. So folks who are designers who aren't currently using 3D software, do you guys offer, either in-house coming in to do training, or do people come to your headquarters, or do you do webinars like this that are in depth on training within your software? What kind of training opportunities are there for folks?
Yes, we do provide training for Pantora in particular. That one we organize directly from our office here, and typically, at least in this particular case, we are taking most of the time that training happens in conjunction with purchase of an instrument, but that doesn't mean that it has to be that way. The other 3D training, such as with our software partners like 3ds Max or V-Ray or Autodesk, those would be coordinated through those companies as well.
Right, and I should mention that Dr. Ellens will be with me next week in New York, where we're doing a 3D workshop with Roman CADs to explore CADs issues and do deep dives on the TAC and on the AxF format that X-Rite has. So if you have questions about that, you can go to fdra.org and look under professional development and events. And there's a link on there that you can see the agenda and see where to register if you're interested. So we're excited about that. Another question that came in is, what kind of physical properties do you store with the AxF file?
So the physical properties right now are not actually measured. If you're talking about the difference between physical and optical properties, so I know that physical properties such as stretch and shear and a few color fastness and a few other things like that are fundamental properties that are associated with fabrics. These kinds of things can be stored with it, but they're not generated, and so you would need to store them yourself. However, this can be managed through the metadata, which is part of Pantora, and you can customize the particular format that you use and enter the data there.
Okay. Another question is, what is the status of AxF support with the Substance Designer? I think that's with Algorithmic, correct?
Yep. Yes, actually, that's a great question. We've had integration with Substance now for probably 8 months, something like that, almost a year. And what happens there is that the AxF file is inserted into Substance, and then Substance provides the tools to extract each of the maps and build essentially a material from them. They actually provide the entire prototype network and convert everything as necessary into the materials that they support. And so there's actually going to be, hopefully soon, a full support for all the aspects of AxF. So right now the car paint is really difficult to put in Substance, but hopefully that will be being solved soon.
Mm-hmm. Okay, another question, folks. Again, if you have questions, please type them in on the webinar control panel on your screen under the questions section. This is it seems like a little bit of a technical question, but it says, do you have a close render real-time view, and that is moving the 3D model and viewing it with high material quality without the need to have a static render?
We have in one of the things I did not show in Pantora is our viewer, and maybe I should just switch back to that because we're still on the webinar, right?
Yep.
So our OpenGL rendering system here is real time. Let me show the snakeskin one because that's one I was dealing with before. What happened? Okay. Here we go.
There it goes.
A little bit delayed. All right, so this is an OpenGL rendering, real time, close up, rotate the view, see the individual pieces of your material up close and personal. The OpenGL implementation here, of course, when there are some advanced characteristics such as subsurface scattering, we expect that there will be perhaps a different way of doing this, and it may not actually be real time because of the complexities involved with that. But for the material format that we currently support, all of this is done in real time.
Okay. Folks, if we have any other questions, I don't see any in the queue. We'll give you just a few quick seconds to type anything in if you would like. Yep. So the response to your viewer is, that's it. Thank you. It looks really awesome. So there you go. Let's see. Here's another question. If you want to use an existing material to develop another colorway, is that possible with the Pintura?
There is a functionality right now, which we are in the process of enhancing, that can extract a color from the diffuse or any particular map, usually the diffuse or the specular color map, and then allow you to replace that color. Right now we're working on making sure that that color replacement has an accurate adjustment with it. So right now it mostly works and you can make it work, but the connection with accurate values is a little bit tenuous, and so it's listed as a beta feature at this point.
Okay. Folks, any other questions for the good of the order? Dr. Ellens, do you have like a screenshot of your contact information or where they can get more information on X-Rite, or maybe you can just tell your email and tell the URL for the company website.
Right. So first of all, this X-Rite.com TAC, which is in the Quest Q&A here, you can find any information related to that on that website. My contact information is just Mark Ellens, all fully spelled out, no spaces, no dots, at xrite.com.
Okay.
No dash.
Great.
No dash.
No dash. Okay. All right.
No dash.
And as I said before, Dr. Ellens will be with me in New York next week for the 3D Summit, where we'll be exploring more of these issues about a roadmap to digitization and deeper dives and best practices around those issues. So if you are in the area and you can make it up to New York, please do come and visit. We still have some seats remaining for that. And I'm happy to say that the X-Rite will be sponsoring several of our summits in 2019, while we'll continue to explore these things and talk about software such as this and hardware like their tax scanner. So I'm excited about that, and we appreciate their participation with the footwear industry in that way. And with that, I think there's no further questions. So, Dr. Ellens, I don't know if you have any key takeaways you want to cover before we wrap up, but feel free to do that.
I just want to make one comment on your invite to the FDRA event next week. We do have a system in the New York in Manhattan area, not too far from where this event's being held. So if you would like to actually see the hardware, please contact me ahead of time and we can arrange an off-site visit.
Great. And I'll testify that it's really cool. I have seen that. I went by and visited when they had a booth set up at Magic in Vegas, and saw the scanner and saw the physical machine that gives the visualizations where you can move your head around and see different angles of the shoe move with you. So it's very cool. So definitely take them up on that. With that, I want to thank Dr. Ellens for coming and giving this presentation today and doing a deep dive into the TAC and into the file format AxF. And we appreciate you all joining us. We'll be continuing webinar series like this on digital issues to help keep people up to speed and educated on different opportunities and solutions for their businesses. Again, Dr. Ellens, thank you very much, and thanks everybody. Thank you everybody for joining. We're recording this and we'll send this out to the entire list after the fact, so you can view it in real time. And if anybody would like to request the deck, they can email. Probably the best email is either you can email Mark directly. You heard his email address, markellens@xrite.com, or you can contact info@fdra.org, and we will direct you to Mark directly to communicate with him further and get the deck directly through that channel. So with that, thank you very much, and until next time, Team FDRA is out.
All right, thanks everyone.
Thank you.